you've probably seen me around. This is kind of a follow-up mixed with WWDC on a presentation I gave a couple of months ago about building custom publishers. I'll talk a little bit more about that in a minute, but for the time being, let's see if I can actually make this go, or whether my run of good luck with tech is failing again. Cool. It is working, hooray! So, Async Await came out, and everybody cheered because it's been coming with, if you've been watching the Swift evolution process, that's been going on for about 4 or 5 months now, and Async Await has been available in the nightlies for a long time, but I'm very lazy and couldn't be bothered actually running any of those up. So Tuesday was the first day I got to play with Async Await, something that I've been looking at for a long time. But the problem is we're very heavily invested in Combine in the code base that I spend my days working on now. So the first thing I wanted to know is, especially given the radio silence from the Swift evolution team, how is Combine and Swift Async Await going to work together? And the answer is, we don't know. If you try and search for Combine presentations in this year's WWDC, you'll get a big fat 0. So there's still continued with the radio silence, especially from Apple this time. And that is very disconcerting, especially for the future of Combine if you've invested in it as much as we have. But all is not lost. There are actually ways to do this. And I will give a very quick disclaimer before I go any further than this. All the code that I'm about to show is up on GitHub. You're more than welcome to play around with it. It probably will set your computer on fire, so no warranties are offered. I guarantee you I've done something wrong there, because this is very complicated stuff that I'm still struggling to get my head around. But yeah, we'll see how we go. So the 3 things I want to talk about quickly. One is creating a publisher from an async function. So that is, so you've got an async function that you can then put inside a publisher. The publisher will emit when the function returns, or it will fail with an error. The second one is mixing async functions into your publisher chain, so being able to map through an async function. And the third one is awaiting the results of a publisher. So having a normal await statement work with a publisher. All 3 are possible. They get a bit more complicated as we go down the tree, but I'm going to assume that if you're watching this, that you have seen the async await and structured concurrency talks in WWDC this year. If not, and you're watching this on delay, pause now and go watch those first, and then come back to this. If you're watching live, then you'll just have to play along with me, but I will point out which talks are good to go and see which bits of what I'm talking about. So let's dive in. So just a little bit of background there. So we have 2 little async helper functions here, because finding async functions are actually kind of difficult finding a meaningful example for this is very hard when you can't just grep the documentation for async, because that just returns a whole bunch of stuff. So anyway, 2 really simple async functions. One returns a string, one will throw an error, so on and so forth. Now, Future seemed like a really good candidate for this, because if you're familiar with Combine, Future, it will emit or fail once. So it emits one value or it fails. And which is pretty much exactly what an async function does. And probably the most likely candidate for people moving their Combine code over to Async Await later on. So this was the goal that I started with. Basically what I was trying to build was a feature that takes a asynchronous closure and then emits the result. Seems like it shouldn't be too difficult. And it turns out it actually wasn't. So this is literally all we needed to do for that. We define the async throws closure that we accept as the input parameter. We do our normal future init. So our normal future init where we get the promise in. And then we use this little convenience function here called async. Now in the next beta or the beta after, this will change into task, the task initializer. But for now it's async. This tells Swift that you want to run whatever's in this block of code asynchronously. You can't actually see my mouse, so that's not helpful me highlighting things. Tells you what's in that block of async code to run it in an asynchronous context, even if you're not in an asynchronous context. So inside the asynchronous context, then we can await for the results of other functions, and all we do then is call our closure using try await. If that succeeds, the promise will be passed to the future will emit. If it fails, we pass through that error. And that actually works. It works pretty well. But if you've seen my talk from a few weeks or a few months ago, what happens if the subscriber to the future cancels? Or what about back pressure? What about cold publishing? Because that's going to run everything immediately. So we can actually take a look at how async function works. It's just a function that creates an unstructured task and returns a handle to that task with our task.handle there. And if you have a look at the definition of the task handle, it actually has a cancel function on it. It has a few more other ones as well, but given that we can cancel that using a task handle. Now I think I'm saying task handle. All we need to do is somehow capture the result of that async back here, and we're good. We can then pass the cancellation up if we need to. Unfortunately, because we're inside a single function and we can't just add stuff to future, we have to go a little bit further. Now, I gave a talk. This is part of that talk that I gave in custom publishers and creating a custom publisher. I'm going to skip out all of the gory details on how to do this. Go back and see that other talk from April, I think it was. All the source code's on GitHub. You'll get a link to that at the end. So really, all we do here is we create a publisher. I've called it TaskPublisher because that's what it is, which accepts the closure as its input. And then to actually deal with the demand from our subscription, when our subscriber requests demand, we save the result, that handle that we get back by calling detach. Now, detach is exactly the same as async, except where the async function, or a partial async task or an unstructured task or whatever it is, by default, it will inherit its parent's closure. So if you're running on the main actor, for example, the tasks that you run inside async will also be on the main thread with the same level of priority. Detach lets you take that, throw it out the window, and start a brand new context with an optional priority if you want to add your own priority. So we'll run that async closure that we've been passed in, and then all it does is asynchronously runs that closure, returns the output. And then we've got the value down the bottom there to actually, when we get the value back from our closure, send it to our subscriber, and then we close off the publisher, so it behaves the same way as future. Once it emits, it completes. And the other part of that subscription method is the cancel function. So when our subscriber calls cancel, we just pass the cancel straight up to our task handler's cancel, so the task itself gets cancelled. And that works well. I wrapped it in a nice little with publisher function. So you can now just call with publisher with your asynchronous function closure, and then treat it like a normal publisher after that. So the reason I went with publisher, and there's also a with throwing publisher, is because Apple has seen that that's the standard. They're currently with task group and with throwing task group, with continuation, with checked continuation, with throwing checked continuation, a whole bunch of these with functions. So with publisher sounds good. All right, so mixing it up. Again, examples are hard. So this is a contrived one. Let's say we were to try and implement the asynchronous URL session. That should be data task publisher, not data task, but that's okay. Let's just pretend that says URL session.shared.data task publisher, and that it returns the publisher version of this. And then it has the, we can provide a asynchronous map that lets us run the async closure in an asynchronous context and emits the result. And then we do something with the result. And that's actually really easy because, oh wow, Keynote, what have you done? Okay, the stream is correct, but the Keynote window is not. There we go. That's really easy because we've already got that task publisher. We can just treat it like a flat map. We can take the value that we get in to the flat map closure, and then we just return our task publisher, and we're done. Like that's literally all there is to that. It's very straightforward. Now another contrived example, and again it should say data task publisher instead of data task. Someone did not vet these slides that I put together 10 minutes before we were supposed to be going live. But let's say you wanted to implement exactly how, or very similar to how URL session does its asynchronous data task loading. So let's say we call our data task publisher. We then map it to get the data out of it. We call first because we want a single result and then we want it to close. And then we have a little function here called get, which just tells us that it takes that, the combine context and your combine publisher and awaits the result of that publisher. So for this example, Apple provides support for continuations. Now, continuations are the way that you take an asynchronous code, you pause your asynchronous code, or you suspend the asynchronous code and tell it to pick up again in a moment. Sorry, this is the with checked continuation one that Apple provides. And it basically is just a block that passes in a continuation struct, and then you call resume on that with the result of whatever it is you're doing, and then the asynchronous function picks up and runs off with that. Check the exploring, I think it's exploring structured concurrency talk that's currently up on the developer app. They go into a lot more detail on how exactly this works. The checked continuation one is really good because it does the whole checks all of your code paths to make sure that you resume on all of the possible code paths. If you fail to resume on any of these code paths, your code will just hang. And I spent an hour debugging Xcode trying to figure out why the simulator was doing basically nothing. But it turns out it was actually just waiting for the publisher to emit, and it wasn't. So this then is our we create a custom subscriber for this one, which we went through how to do in the other talk. It's just, again, a simple function where we get our custom subscriber and it subscribes to the publisher that you pass in. And then we use a task cancellation handler, which is also very helpful. It allows us, if the task is then cancelled, to then cancel the upstream publisher. So we're being nice citizens that way. And then we use the with unsafe throwing continuation because Apple guards against you passing the continuation into an escaped closure, because then that is apparently they can't check it for safety anymore. So guarantees when you put in the with unsafe bit that you're going to set something on fire. But basically all we do then is the subscriber has a little function where it takes a block and the block expects a result to come back in from the publisher itself. So the publisher emits a result, which is the output value or a failure, and then we just resume the continuation with that. So in better words, when we get into the get function, our asynchronous get function, we suspend the operation until the publisher has emitted a result, and then we continue with that result. Apple slides are way better at explaining how all of the pieces there work. Go check out what they've got. And that's it. That's all I've got. If you want to go and check out the source code for all of this, it's at github.com/unsignedapps/combine asyncually. And yeah, I'll post a link for that in the Slack channel as well. It has everything you've just seen, plus it's fully tested or mostly tested. Gio will be happy to know that. It's almost impossible to test task cancellation, but yeah, I've gone as far as I can in the short time that we've had so far. We'll see if we can improve that in the future. hopefully someone smarter than me can look at that and go, hey, yeah, you've got, this race condition and that race condition and all that sort of stuff. But yeah, thanks very much. Back to you, Baz.